guys, welcome to another episode of MrLopezClasses.com. This is our marine auxiliary book. In this chapter, this is the chapter number 4, we are going to talk about the windlass and the anchors. Yes, we are going to learn the procedure to install the windlass, the different type of windlass. We are going to calculate the capacity of the motor, and we are going to check the factors that affect that selection, the selection of the appropriate windlass. Yes, we are going to do that process, and we are going to select the chain, we are going to select the length of the chain, and we are going to select appropriate the motor, if the motor is AC or DC or hydraulic. Yes, this is a wonderful chapter. It's dedicated to windlass. Okay, my friends, exactly the same like in other systems. We have basically 3 options. We have electrical DC motors, reversible motors, because those motors are excellent for small and medium boats. We have electrical AC motors for big boats, and we have hydraulic systems for mega yachts. The advantage of the hydraulic system is that you can integrate this system, the anchor, you can integrate this system into the central hydraulic unit. And in the central hydraulic unit, you have a couple of outputs for the windlass. And yes, you can administrate all of the hydraulic systems integrated in one unit. This is the advantage that we studied in previous episode, and we are going to check in the next coming episode that all the systems can be integrated in that central hydraulic unit. Okay, we are going to start to check the typical electrical DC hydraulic installation. That installation, this is a wonderful installation. And yes, in the next coming video clip, I am going to explain in details. This is the windlass, this is the motor, reversible motor for, this is a corner clock rotation, and this is a clock rotation. This is the ground connected to the negative bus bar, and the battery bank, the negative of the battery bank connected to the negative bus bar, and the positive of the batteries. In this particular case, this is a 24 volts connection because they are connected in series. The positive enter in the middle of the solenoid control box, and one side for corner clock and otherwise for clock rotation. And the signals are coming from the foot pedals. Those are normally open momentary switches, and those switches are located in the pulpit in front. Those switches are exactly like the switches that I have on top. Normally open momentary switches. The positive enter in the middle to communicate both of them, and the external signal for up and the other signal for down. Yes, I can administrate the windlass from those switch pedals or from the switch that I have in the console, up and down, this one, and I send the signal for up and down. Yeah, you have a double command from this switch or from the pedals on the pulpit. This is a simple installation, and we are going to follow the procedure that I explained in the electrical class about how to reverse DC motors. No? In the video clip, how to reverse AC motors and DC motors. In that video clip, I explained the procedure to rotate AC motors and DC motors. Remember, the DC motors can be rotated in opposite direction with the solenoid control box. And the AC motors, you can change the sense of rotation with the contactors. With contactors, you change the rotation in AC motors. In that video clip, I explain easily, in a simple way, in a funny way, how to do that procedure. Okay, my friends, and we are going to check in general terms the nomenclature for the windlass. This is the deck. This is the deck in fiberglass. This is the deck in fiberglass here. And in this particular case, this type of windlass is considered vertical. And the name of this element is the gypsy. And in the bottom you have the electric motor. This is the electric motor, 12 volts or 24 volts, and this is the gearbox. That's the gearbox over there. This is the typical components of a windlass, and now we are going to analyze how those windlass should be located. Basically, when you select the windlass, you need to take in consideration the displacement, the windage, anchor, the size, and the row selection. Those are the factors that you need to take in consideration when you select the appropriate windlass. All right, and now we are going to check the procedure to connect this windlass in a small video clip that I prepared for you.
Yes, for example, in this particular case, this is the motor for the windlass. And I can activate that motor, DC motor, from the solenoid control box or from a couple of relays like I explained in the video of how to reverse rotation in DC motor, reversible motors. You remember that video? Okay, this is the video that I explained with this board. In this particular case, this motor is for a windlass. For a windlass like this is the typical windlass, and the windlass enter in the shaft of this motor. And that windlass can be activated with that motor. This is the typical windlass for a medium boat electrical windlass. How is the troubleshoot? In this particular case, I have the perfect scenario, because in this particular case, the solenoid control box is not working. It's damaged. If you check, those are the controls, the blue one for one direction, the yellow one for the other direction, and the red one coming, the power coming from the middle, from the switch selector. In this particular case, it's not working, but I need to verify where is the problem. If the problem is on the motor, or if the problem is on the solenoid control box, or if the problem is on the switch. This is the switch that I put in this particular case, a manual switch, but this switch can be the foot pedals. A typical windlass, those switches can be replaced for foot pedals. Those pedals for up and down. This one is for up and this one for down. And in the bottom they are momentary switches, normally open switches. When you close the gap and the current pass. How is the wiring? The wiring is like this, the wiring of those foot pedals. For the windlass on the pulpit, exactly like the pedal that you have on the screen. Or a switch like this, momentary switch. Alright, let me verify if the problem is on the motor. If I bring power directly to this point at this point from the battery and the motor start, is because the system is because the motor is in good condition. Let me bring with a big cable. I bring power directly from the positive bus bar directly into this point. This is good for one direction and good for the other direction. The motor is in good condition because I bring power directly with a big cable, battery cable, directly from the positive of the battery directly into the positive, each terminal positive of the motor. My motor is okay. My electric motor is good. Let me verify if I bring power directly from the battery into each output of the solenoid control box. It's okay. Let me verify. That's okay. Oh, the output of the solenoid control box, the terminal between this and this is okay, and this is okay. Let me check the signal. Oh, that's the problem. And the other one. Let me go into the switch. Oh, the problem is not the switch. The problem is not the harness in between the switch and the solenoid control box. The problem is internally the solenoid control box. What is the solution? I need to replace the solenoid control box or replace the solenoid control box for a couple of relays like this. And I am going to connect, in this particular case, in parallel, this with this to demonstrate that with the relays is good. How I connect the relays? Once again, in the middle, in between both relays, I receive the power from the batteries. I receive the power in the middle. And from one side of the relays, I enter in counterclock rotation. From the other side of the relays, I go into the clockwise rotation. And this relay receives the signal from the switch or foot pedal, and the other one receives the signal from the other side. With the relays, the system is working. With the solenoid control box, it's not working. In that case, I can replace this for this. The only that I need to take in consideration is be careful with the capacity of the relays, because the capacity of the relay should be equal to the capacity of the control box in amps. That's it. This is the process, and you can replace that solenoid control box for a couple of relays. This is the simple process to connect the windlass, like the diagram that we have on the screen right now. This is a perfect diagram for the connection. We have in the console the switch up and down. This is the switch up and down. And we have the solenoid control box. The solenoid control box receives the signal, the yellow one and the blue one, from the switch up and down. And we have the connection to the battery. And we have the motor with the both positive, exactly like the diagram, and this is exactly the connection for this diagram. This is the typical electrical windlass.
Okay, now it's clear that the windlass can be installed in a horizontal or vertical. This is vertical, and this is horizontal. All right. It's not because the motor is vertical or the motor is horizontal. No. Is where is located the gypsy and the motor. In this particular case is vertical. Of course, the motor is below the deck. Right now I am going to give a couple of examples in order to clarify the difference in between horizontal and vertical. The thickness of the deck and the room for the chain are vital factors in the selection of the appropriate anchor. Yes, this is the typical vertical configuration. You see, this is vertical. That's vertical, and in this particular case, this is the motor, and this is the gearbox. All right, and this is the room. That's the room that you have for the chain and the rope, and this is the locker. The locker for the anchor, right? And yes, this is another view of the vertical configuration. The vertical configuration have a capacity of around 1800 tons. That's good. This is a great capacity. And the horizontal configuration have a capacity of 900 ropes. Yeah, depends of the diameter of the chain. Right now we are going to check that important factor. This is a good example of a horizontal windlass. Everything is located on the deck. This is a wonderful windlass. We are going to check later and a similar windlass like this in a hydraulic system, in a boat completely hydraulic, where the windlass is integrated with the central hydraulic unit. Okay, and yes, this is the typical question: how much space do I need in my change locker? Good question, but that depends on the thickness of the deck and the room, the space that you have in the locker. That's the situation, and this is a great example of the vertical and horizontal configuration. If you see, this is the vertical configuration, and this is horizontal because everything is located on the deck. Yeah, normally the horizontal configuration is better because you can collect more chain on the locker. Once again, depend of the amount of space that you have in the locker, you can select a vertical configuration or horizontal configuration. Yeah, this is the factor that to take the decision. Exactly the same with the AC and DC motors. I consider that the DC motors are excellent for medium, small and medium boats, boats until 55, 65 feet. For boats in between 65 and 95, I recommend AC power. And for mega yachts bigger than 100, I recommend hydraulic systems. It's very, very important, that recommendation. Okay, and now we are going to check how the procedure to select the appropriate motor. But basically the most important part is the force, the pulling capacity, the force that I need to recover the chain and the rope and the anchor. Okay, how much is that force? This is the formula, the easy formula to calculate that force. The formula is like this. I need calculate the total weight, the weight of the ground tackle. What is the meaning of a ground tackle? Is the anchor, the chain, and the rope. You added all of this, anchor plus chain plus rope, and you calculate the total weight. Okay, if you multiply, the force is equal to the total weight times 3. And this is the force, this is the pulling capacity. This is the pulling capacity. Okay, and with that force, you can select the appropriate windlass, AC, DC, or hydraulic. And also, depending on the space that you have in the locker to storage the chain. Okay, this is the pulling capacity used to select the appropriate motor. And about the selection of the chain, it depend of different factors. There are different type of chains, but this is the magic formula. Sizing the chain. The first step is what is the length of the boat, and how much is the total weight of the boat, full loaded. Okay, I need the length and I need the total weight, and with that information you can use nautical charge to calculate, depending where you use the boat, how deep will be located your boat. With that information you can use this table. In this table I recommend, for example, for boats in between 31 and 35 feet, this is the length of the boat, and the total weight of 10,000 pounds, this is the thickness of the chain, 5/16. Oh, my boat is 60 feet, this one, and the weight of my boat is 48,000 pounds. Okay, it's okay. The thickness of the chain recommended for your boat is 9/16. This is a good table. I recommend, when you have a chance, use that information in order to select the thickness of the chain. Very, very, very important recommendation. Okay, and the last one is how long, the length of my chain. And basically the recommendation is your chain should be no shorter than the length of the boat. The recommendation is where should be located your boat. Calculate the distance in between the ground and your boat, and multiply that distance in between 7 or 10 times, and this is the length of chain recommended for your boat. Okay, and now we are going to analyze exactly the same system for a hydraulic anchor, hydraulic windlass. And once again, I am going to visit a boat where all the systems are integrated. And yes, the servo valve units are located behind of the locker where the chain is located. This is basically the hydraulic system and the anchor with the horizontal system. This is another great example of a central hydraulic unit. The pump is coming from the PTO or from the electric motor, AC motor. And this is the body of valves with the servo solenoid. We have a couple of servo solenoids for valve thrusters, and we have another body valve with servo solenoid for the windlass. In this particular case, this valve body integrates valve thrusters and windlass. And the solenoid for the valve thruster receives the signal from the joystick, left side and right side, steam thruster, left side, right side, and windlass. And windlass with the two solenoids, one for up and other one for down. And this is the locker where the hydraulic unit with the servo valves are located. In this particular case, the hydraulic unit is used for both purposes: for valve thrusters with the servo solenoid for valve thrusters, and the servo solenoid for the anchor.
This is the anchor system with the external chains. The control. Port side and the starboard side, two chains. This is the compartment, and those are the main controls. The main controls up and down per each chain. And this is the chain. And this is the final end. The final end of the chain is with a piece of rope, and the rope is anchored over there. And those are the motors. Those motors are hydraulic motors. You remember I explained before, those are the hydraulic motors, that the input and that the output of the pressure. That's the hydraulic motor, and this is the unit, and this is the chain for the starboard side, and this is the chain for port side, and this is the other hydraulic motor. Those hydraulic motors receive the fluid from the central hydraulic unit that you have on the screen right now. As you can see, those chains are in perfect condition. This area is a completely dry area in order to avoid interference in between the chains and any other obstacle. This is a perfect compartment, completely clean, completely dry, and those are the hydraulic units, and those are the controls for the port side change, and this is the control for the starboard side change.